Happy morning, dear friends. Here's yours, Dr. Ajanta. Welcome to Demystify with Ajay. Dear friends, previously we have just discussed about evaluating the performance of the model. And yes, that exact model, it is on a regression model. And today we are going to discuss the same evaluating the performance, how to evaluating. So accessing the model performance for classification model, that is what we are going to discuss. Before going to do, I want to share some few important things. Dear friends, building machine learning model is based on the principle of continuous feedback. So the machine learning models are built and the model performance is evaluated further. Models are improved continuously and continue until you achieve a desirable accuracy. And here, model evaluation metrics are used to explain the performance of metrics, and model performance metrics aim to discriminate among the model results. And making a machine learning model and carrying out prediction is a simple task, but your end goal is to create a model that gives high accuracy on out of a sample data. Hence, it is important to check performance metrics before carrying out the prediction. Dear friends, in AI industry, we have different kinds of metrics in order to evaluate machine learning model. And yes, today we are just going to discuss all about the classification model. Okay. Classification model are used for predicting which class a group of features will fall under. And yes, when we consider a classification model, yes, you might start to ask yourself how accurate the model is. But how do you evaluate accuracy? So you need to create a classification model before you can start accessing it. So let me just take a car data set. Okay, I just took a car data set from UCI ML repository, and yes, you will use this data to classify cars as either acceptable or not acceptable based on the some categories. And here, what are all the categories is, I have specified here. Yes, before that, I just execute this necessary libraries. Okay, so these are the important libraries that I have to include it, and of course to split the testing and training, I just included here. Okay, now let me just move on. Of course, under classification, yes, we are going to discuss this logistic regression. I think after two sessions we would discuss in depth of mathematical intuition. Now let me just create a model here. Okay, so when on just creating the model, kindly just observe, dear friend, here we have the attribute as like buying, that is the purchase price of the car, and this maintenance, that is the maintenance cost of the car, and number of doors, that is what here it is specified, and the carrying capacity of the vehicle, how many persons, like that, and the size of the luggage boot, it is specified here, and last but not least, yes, the safety estimation. Okay, so the estimated safety of the car, and yes, here we have this, the exact car, it is what the target. Okay, so the target column, and yes, first of all, let me just have this data, and let I just include it. And yeah, dear friends, here specifying before, of course, we have already imported this train test split, which is needed for splitting data into training and evaluation data set. And yes, here we have also imported the logistic regression, that is the exact class. Okay, now what we have, these are the exact header, and we are having the data frame. So the data frame name, it is df, and here kindly just observe, dear friends, here towards this, of course, we have already discussed about this get dummies. Yes, we have some categorical variable, and here to encode categorical variable we have to use this particular code. And yeah, you convert the categorical column into numerical column by using the technique. Of course, here, yeah, I didn't specify here, but anyhow, I let you know it is one hot encoding. Okay, so this is one hot encoding. Okay, so yes, by using this we have created this snippet, and yeah, you need to do this because the input to your model must be numeric. You get numeric variable from categorical variable using this get dummies. Okay, and yes, from this pandas library. Of course, we have already discussed a lot about this in the future engineering model. And dear friend, here we're not just making it, yeah, of course, a new data frame has been called. So making as a differentiation here, this underscore df has been given. Okay, so you are providing this df as like a specified column of this as an encoded functionalities. Okay, and let me just have the output. Okay, so see here, these are the output now resembles that dummy, that is one hot encoding resultant. And kindly just observe each and everything a dummy things has been created, that is buying high, buying low, buying medium, and buying very high. The same thing, maintenance high, maintenance low, maintenance medium, maintenance very high. Okay, dose also, there are so many doses there too, and 4, 5 more. And here persons 2, persons 4, persons more. Luggage, boot, big, medium, small. Safety, high, low, medium. So these are the exact category. Okay, so this encoded category now created with a dummy. So that is one hot encoding combined. And yes, let me just move on to the next one. Okay, so see here. What are you doing in this step? Of course, we have already seen the same thing in the regression also. Anyhow, I just explain it again. Yes, dear friends, you being by extracting your future columns, okay, and your labels by using this numpy array called this futures and labels, and you then proceed to extract here splitting. And actually here I just specified 80 and 20, but actually here we have just given 0.3. So 0.3 is in the sense, yes, here it would be as like 70% and 30% for evaluation. Okay, I think so. So here 70% into X train and Y train, with the remaining 30% it is going into X evaluation and Y evaluation. Okay, and you then further split this evaluation into two equal parts, that is X eval and Y eval, into two equal parts, and assign those to this X val and Y val for validation, and this X test and Y test for testing much later. Okay, so that is what into two parts, that is what here it is specified. Okay, that is fine. So let I just execute this. Now what is next? Of course, you are creating an instant of this logistic regression and train the model on your training data by passing in X train and Y train to the fit model. Y train, X train and Y train to the fit model. Okay, what would you just get? Can we get? Yes, of course. Kindly just to see, you just get this particular output. Okay, so what it just seems as like a training logistic regression model has been done. Okay, next it is all about prediction. Dear friends, here what we are doing is, yes, of course, you make a prediction on a validation data set xval and store the result in Y prediction. And look at the first here, the first 10 prediction by executing this Y prediction of 0 to 9. That is, that first 10 prediction should provide a output. Let me just see what is the output here. Okay, this is what. Okay, so prediction for a validation set, that is what given here. And observe one thing, dear friends, this model works because you are able to use it to make prediction, and the prediction classifies each car as acceptable, unacceptable. Okay, so see here, this is unacceptable, acceptable, unacceptable, unacceptable, and next two are acceptable, and here we just got a very good, and again unacceptable, unacceptable. So first 10 records we are just getting it, and yes, you are ready to apply various assessment to this model. Okay, what we are just going to do, yes, first of all, let me just follow, that is here we train the logistic model once, so that we don't need to do it repeatedly, because the number of steps involved here. Okay, so with this, once the model is done, we discuss only the evaluation part today, and how to create the model, and how to what is the back intuition of the model. Yeah, we are going to discuss it further in each algorithm with a project separately. Okay, yes, so here first we are having the classification model. Okay, dear friends, as you are already specified, we are not much entering into the data, but for creating a model, we have to know each and every attribute. And of course, I have already specified, whenever you are creating or choosing an algorithm, of course you have to know 360 degree of the data, whether what is the data it is of, what is the structure of the data, what is the type of the data, and how you are going to utilize it, where you are going to store it, and how the exact whether the data is authenticated or not, and all such the memory part. So everything you have to know, and with that only we can proceed further. So these are analyzation which we just do it in step-by-step process of exploratory, and we do pre-processing, then we just make a future transformation, everything. But here, just to know the evaluation part alone, we have just not even to run away, just we have created a model, and we are jumped towards this evaluation. So kindly just be aware, dear friends, we are going to discuss each and every model in depth in coming sessions. Okay, yes. First of all, the first evaluation, it is all about confusion matrix. So a confusion matrix is a table. Of course, you are able to see this table that outlines different prediction and test results and contrast them with real world values. And yes, mostly this confusion matrix is used for in-depth analysis of statistical data efficiently and faster analysis by using data visualization. And here what we are having, so kindly just observe, there are so many things are there. Yes, here it is the true condition, here it is the predicted condition, and we have a true positive, false negative, true negative. Okay, and yes, here we have some calculation related to this true post rate and false positive rate, false negative rate, and true negative rate, and positive predictive value, and false discovery rate, false omission rate, negative predicted value. Wow, so many things are there, so many technical values. Of course, dear friends, these are the terms used mostly in confusion matrix. But what is the most used are? Yes, the first one is accuracy. The second one is a positive predicted value, which we just specify as like precision. And next negative predicted value. And next we just go towards recall, and yeah, come towards this F1 score. Of course, today we are just going to discuss one by one. Okay, yes, this one actually when we just create it, let I just go to the code and then come towards it more on towards this confusion matrix. Okay, dear friends, this is the exact step. You import confusion matrix from sklearn. Okay, sklearn metrics. This is the evaluation matrix. Okay, so this function will let you generate a confusion matrix. So I just execute it. And next here, this exact steps, confusion matrix, would generate a confusion matrix by supplying y value, the actual classes, and the y prediction, the predicted classes. Let me just see what the output is. Okay, so see here, we are having an output like this, and of course, we can see that our data has 4 classes. And the first column shows all the data that should belong to the first class. The first row shows number of prediction that were correctly placed in the first class. And in here, in this example, yeah, the number is 41. So the second row shows the number of prediction that were placed in second class but should have been in first class. So that comes here as 7. And here in third row, yes, of course, you see the number of items that were predicted to be in to be in third class, but should have been in first class. And the number is 7. Okay. Finally, the fourth row, you see the number of items that were wrongly classified into the fourth class when they should have been in the first class. So in this, the case number is 1. What this confusion matrix helps you? See, actually it just helps you to analyze the impact of choices you would have to make it if you put the model into production. So let consider an example of predicting the presence of some disease like that. Of course, if you are not aware of this car or whatever the thing, let me just take something as a presence of disease. So based on some input to a model, if in such case, let me just take a binary classification. Here we have 4 classifications. So let me just take a binary classification. So in that binary classification, let I specify, okay, if we are having that is 1, yes, the disease is present, and 0 not. Okay, so 0 implies the disease is absent, and here it is present. So the confusion matrix for this model would have 2 columns and 2 rows. 2 columns and 2 rows. Okay, so the first column would show the item that fall into class 0. The first row would show the item that were correctly classified into class 0, which we just say true, negative. The second row would show the item that were wrongly classified as 1 but should have been 0, false, positive. The second column would show that item that fall into class 1. And here the first row would show that item that were wrongly classified into class 0. So when they should have been 1, and yeah, it is false, negative. Finally, the second row here shows items that were correctly classified into class 1. This is class 1, okay, and called true, positive. Here, dear friends, false positive or false positive or the cases in which the samples were wrongly predicted to be infected when they are actually healthy. That is mainly here, kindly just observe. And towards the thing, the implication of this is the case, yes, would be treated for a disease that they do not have. And when coming to this false, negative, yes, these are the cases that were wrongly predicted to be healthy when they actually have the disease. So the implication of this is that these cases would not be treated for a disease that they actually have. Now I just know that exactly your question, the question you need to ask about this model depends on the nature of the disease and require domain expert about this disease. Now, for example, if the disease is contagious, yes, then the untreated case will be released into a general population and could infect others. So what would be the implication of this versus placing a case into quarantine or observing them for symptoms like that. So if we just go for a COVID, in such a case, I'm specifying. On the other hand, if the disease is not contagious, here the question becomes that of the implication of treating people for a disease that they don't have. Okay, versus the implication of not treating cases of the disease. So it should be clear that there is not a definite answer to this question. The model would need to be tuned to provide performance that is acceptable to the user. And here I just specify one thing, dear friends, of course. Yeah, kindly let you just see this confusion matrix again. Okay, actually I have returned this true condition here and prediction condition here. So that is what we are having, that matrix formation. So kindly observe, this is true positive. Here we have the false positive. And here it is false negative and true negative. Okay, so kindly just be aware of this, both type 1 error and type 2. Okay, yes, fine. So now let me just move on to the next one, that is precision. Okay, so here I just specified correctly, I think so. Okay, here it is, right. Okay, now let me just move on towards the precision. Dear friends, the precision is the total number of cases that were correctly classified as positive, that is true positive. Again, I just go to this confusion matrix to have you a clear. So this is the true positive. Okay, and here I just come here. Yeah, this is actually and of course predicted also the same. Okay, so this is true positive and abbreviated as like TP. Okay, and here it is divided by the total number of cases in that prediction, that is the total number of entires in this row. Entires in this row. So in this row, both correctly classified this true positive and wrongly classified false positive forms the confusion matrix. Okay, I just let you know the column here. So for okay, I'm just making one sec. Okay, so this one is confusion matrix. Here I just go with precision. Here it is TP divided by TP plus FP, and kindly just observe, dear friends, this is true positive divided by true positive plus false positive. Okay, so this is what. Okay, let me just have the code here. Of course, so yes, as I have already specified, this one we have to import precision score from sklearn matrix. Let I execute, and to evaluate this precision score, to compute it, yeah, we need to compute the score using this precision score, and kindly just observe the exact score. It is 0.81. And one thing to be noted, the output, yes, it is a floating number between 0 to 1. Okay, so the precision score can vary depending on to the data, dear friends. So if in such case here, if for an example here we just get 81, so as the precision score of this classification model is 0.8184, okay, it is specified as like 81.8, so let me round it out as like 82%. Okay, so 82% could be a good score and is acceptable in some domains, but is a low score in certain domains also. So there is a scope for improvement. And yes, think of the precision score as asking how often does this model make the correct prediction for a class. So the value needs to be much closer to 1 than the score we just achieved. So that is the exact point you have to be noted. Okay, next we are calculating about the recall. Dear friends, recall is the total number of prediction that were true divided by the number of prediction for the class. So both true and false. Okay, so both true and false, and think of it as the true positive divided by the sum of entries in the column. Of course, I just go back again. Here I specify the third one, it is recall, and here it is true positive but divided by true positive plus false negative. Okay, true positive and false negative. So I just go towards the new thing. So actually here we just have the actual and testing. So I just take actual data here and prediction data here. So you can just have this matrix as our combined. So true positive, false positive, and false negative and true negative. So see here, dear friends, when you just take for this precision, yes, you are taking this. So this is what the precision. And for recall, of course, you are taking this true positive and divided by summation of this true positive and false negative. Got it? Okay, so let me just move on here. Yes, to include or to make compute this recall, of course, we have to import the recall score from the sklearn matrix. And you recall, to compute recall, yes, of course, you need to specify the y validation and y prediction as parameter to the function. And kindly just one thing observe, dear friends, the document of recall score explains the value that you can supply to average. If your model does binary prediction and the labels are 0 and 1, yeah, you can set average to binary. And other option are micro, macro, weighted, and samples. So you should read the document to see what they do. And here, as we are having, yeah, it is more than 2 columns, that is 2 classification. Here we have a multi classification, and we have specified here this as a macro. And let me just observe the recall. Okay, and yes, here too the recall score can vary depending on the data. As you can see here, the recall score in this sample, yeah, we just got 0.722. This means the total number of classes that were predicted is 72%, where 72% of them were correctly predicted. So on its own, this value might not mean much until it is compared to the recall score from another model. Okay, so yes, let's now move towards calculating the F1 score. So which also helps greatly in evaluating the model performance, and which in turn aids in making better decisions. So when choosing model, okay, and kindly just observe, dear friends, this F1 score is another important parameter that helps us to evaluate the model performance. And here it considers the contribution of both precision and recall by using this formula. And yes, here you can just specify if you are getting confusion with this first one, kindly just you can just move on to this 2 into the product of 2 into the precision and recall product divided by sum of precision and recall. And here this exact F1 score ranges from 0 to 1, with 1 being the best possible score. And here you compute this by importing, by using F1 score from sklearn matrix. And let me just have the same. So observe, dear friend, here you compute the F1 score by passing y val and y prediction, and here you also specify the average because this is not a binary classification. Okay, what is the score? Yes, we just got 0.738, and by end of this, yeah, we achieved 73.8%. There is a lot of room for improvement, and you would you can just do some future engineering and train a new model to try and get a better F1 score. Okay, it is not a problem. And yeah, for that you have to create one more model and you have to make a comparative functional. Yeah, next we are moving on to this accuracy. Dear friends, accuracy is an evaluation matrix that is applied to classify model. It is computed by counting the number of labels that were correctly predicted. That is meaning that that the predicted label is exactly the same as the ground truth. Here the accuracy score function exists. Yeah, of course, this also comes from sklearn matrix. Okay, and when on just including this, yeah, here we are going to same passing in y-val and y prediction, and to this the accuracy score as a parameter. And let me just first of all let I include this and going on to this. And dear friends, here kindly just observe the interpreter exactly assigns the results to a variable as like C variable or like that. Okay, and here we just get the print method which just cause interpreter to render the value of this accuracy. Okay, I'm just making this towards this, and yeah, what we just get, of course we just get 0.899. That is, we successfully calculated the accuracy of the model is being 89.9. So of course we can just say 90%. So the goal of this session is to show you how to compute the accuracy of the model and to compare this accuracy to that of another model that you will train in future. Okay, fine. Last but not least, we are jumping towards this logarithmic loss. So the logarithmic loss, shortly specified as like log loss. It is the one loss function for categorical model. Okay, so it is also called categorical cross entropy. Okay, and it seeks to penalize incorrect prediction. And yes, dear friends, in that sklearn documentation, it just defines as like a negative log likelihood for the true values. Which given you a good model predictions. Okay, and yes, here also we are just making use of this sklearn matrix, and we are making import this log loss. Okay, and yes, you compute the log loss and store it in a variable underscore loss. Okay, and you need to observe something very important, that is previously you made use of y-val ground truth and y predict the prediction, but here you do not make use of prediction, instead you make use of predicted probability. You see that the code here where just specific is model, that is the exact model where we created. Yes, I'm just going to scroll above. Kindly just observe, dear friends. Here we just created the classification model, and kindly observe, this is the exact model which we made an instant and fitted. So this exact model's predicted probability, that is what applied here. Okay, and the specific thing here is, yeah, the validation data set, and it returns the predicted probabilities. Okay, now once after printing, okay, what is the interpreter to render here? It is 0.225. Okay, so here we calculated this log loss for a classification model, and of course here I'm not going to stop here. Here I'm just going to add up some important things. Actually, when on just specifying the evaluation metrics onto the regression model, I just got an one important thing, that is where to use or when to use this evaluation metrics. If it's so, any alternatives is there or not? Yes, of course. For this classification model, I just provide you to which model we have to use which methodology. Okay, and one second. So let I just give you, it is a very important. Of course, a few of the subscribers just asked it, and in friendly manner they have just requested. So yes, let I just give you. So there are so many different evaluation metrics are there. When to use which evaluation? An important point. Okay, so fine. So as I have already specified, different evaluation matrix are suitable depending on the specific problem you are dealing with. As like data distribution and the cost associated with the different types of errors, as like different types of errors. Yes, it can be as like false positive or false negative. So these are all comes under errors. And yeah, here I'm just going to give you a small a structure related to that. Okay, so first of all, let me just take accuracy. When to use this accuracy? Dear friends, when the database is balanced, yes, you can go towards this. And it is suitable for general purpose evaluation when all errors have equal cost. And when not to? When not to? So, if it is an imbalanced, don't specify. Okay, or one second, if I think we have just discussed about an imbalanced technique. I think that fraud detection where one class dominated the other. Okay, so in that manner, don't make evaluation as for accuracy. Okay, alternative, what is there? Yeah, other things are there as like precision, recall, F1 score. You can just go it, and if you can care more about false positive or false negative, you can just go to that off. Okay, yes. Now let me just go for the second one, precision. And this precision, when to use this precision? When you have the false positive or costly. For an example, if in any spam detection, if you want to minimize classifying legitimate emails as a spam, yeah, you can just evaluate by using this precision. And when not to, of course, kindly just observe if the false negative or more than false positive, don't use precision. Okay, don't use precision. Okay, now next let me just move on to the third one, recall. And coming towards this recall, when to use? Yes, when false, negative or costly. For an example, in medical diagnosing, some missing a positive or positive categories or which it can have a serious consequence. If in such a case, yeah, you can just go for recall. When not to, of course, here that is the opposite for this precision. Yes, when not to, if the false positive or more important, don't use recall. Okay, fine. Alternative, yeah, we can just, if it is in the case, yeah, we can just take this as your alternative. Okay, and next let me just move on to what we have left. Yeah, F1 score. Okay, F1 score. When to use it? When you need a balanced precision and recall. When you have a balanced precision and recall, F1 score is especially useful when you have imbalanced class. And here, of course, ideal when false positive and false negative are equally costly. Okay, now when not to? When not to? Of course, when you can clearly prioritize precision over recall or recall over precision, don't use this F1. Okay, so here it is of prioritizing. And last but not least, let me just have the log loss. When to use log loss? Okay, when you need to evaluate probabilities that is produced by a classifier rather than the just the hard prediction. When you want to evaluate probabilities, of course you can go with this. And yeah, in this scenario where it is important to penalize confident but wrong predictions more heavily. This term example I can just say something as like financial risk modeling. Okay, you can just have like that. And when not to. When not to, of course, here for the problems where you only care about final class prediction, not the probability. So if it is only the prediction, no, don't use this log loss. If you are needed on probability, go with this. Okay, yes, yeah, dear friends, I think we have discussed a lot about this functionality. Okay, and yeah, I just make a separate this one, when to use and when not to for the regression models, so that yeah, as a short, and I just include it in the description. Okay, and hope, I think so this exact session or this exact video would be useful for you to evaluate. Okay, to evaluate the classification model. And yeah, if you find this video very helpful, yeah, don't forget to hit the like buttons, subscribe to the channel, and turn on notifications so you don't miss any of my upcoming content. And yeah, dear friends, drop a comment below if you have any questions or suggestion for future topic. And as always, keep learning and stay curious. See you in my next video. Happy learning, dear friends.